Hello, this is Mark Anderson for Keller Community College, and today we're going to learn about quadratic equations and how we can solve them. And in fact, this section here is going to first start off by saying, like we've learned before, we should try to solve by factoring. So we're going to try to solve by factoring, and we're going to use this whenever we can. That is important because factoring is the fastest way, but as you're going to see later on in this unit, factoring isn't the only way, and it can't be the only way because a lot of problems aren't factorable. But in this easy trinomial, we have a problem that I can go and turn into x minus 6 and x plus 4, because those are two numbers to multiply to make negative 24 and add to make negative 2. And to find out what the answers are for these, we set these equal to 0. And by setting them equal to 0, what we then can find by solving for x are the locations of x. Now, what this is illustrating, it is illustrating that this parabola intersects at 6 and at negative 4. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4. It also has a y-intercept of negative 24. If you type this into a graphing calculator, you can see that in the table. Also, if you substitute 0 for x, you could see that the y value would be negative 24 in this case. So that, my friends, would give you this very 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. It would give you this graph, this parabola, which has a very deep swoop, and it wouldn't probably actually be at its lowest point there. Since this is offset, the lowest point would probably be down here in some place called the vertex. And we're going to learn about the vertex later on, but I want to give you an idea about what we're actually doing here. We're actually finding the zeros of the formula when the x hits the ground, but this is a parabola, and this parabola goes down to negative 24 on the y-axis, and it also hits the ground at these, or hits the x-axis at 6 and at negative 4. Now, we're going to learn graphing later, but this is actually what we're doing. Since there's an x squared, the fundamental law of algebra says we'll have up to 2 solutions to this problem. In fact, 2 real or imaginary solutions once we start to get into some of the stranger problems here. But in this case, we're going to see either 1 or 2 solutions for these. And so this is a perfect example right here because we have 2 numbers that multiply to make 25 and add to make negative 10. Those numbers would be minus 5 and minus 5. If we solve for both of these, if I set one or both of these equal to 0, you would get the same answer of x is equal to 5. And this gives you a graph that looks like this. It swoops down and then goes back up. It actually hits the y-axis at 25. That would be its y-intercept. But this gives you an idea of what the graph looks like, because in some cases you will have 1 or 2 solutions. Alright, so with these problems moving on, you see we're going to have some more difficult problems, but they will all be factorable. In fact, this problem here isn't set up correctly yet. We have to move the 10 to the left-hand side, and we'll do so by subtracting 10 from both sides. So 2x squared plus x minus 10 equals 0. And then what we'll do is use tricky trinomial factoring, where I multiply the 2 times negative 10, which gives me negative 20. This scrap work on the side gives me the numbers I have to multiply to make negative 20 and add to make my target value of 1x. So I'll put a 1 there just to kind of remind myself that. The 2 numbers are going to be positive 4 and negative 5, because that will give me my negative 4 and positive 5. Sorry about that. This will give me my positive 1 right there. And now I will split this up, and I will do so by making this a 4x plus 5x. The parentheses I'm putting around this are merely cosmetic. There's really no reason for them. But this is going to become a grouping problem where I'm going to take the first 2 terms and factor something out in common. In this case, it's going to be a 2x, and that's going to leave me with a x plus 2. And then I'm going to factor out, oh, I forgot that should be a minus. so that would be an x minus 2. I'll just put plus negative there. If I factor out of these next two terms here, I'm going to factor out a 5, so there's my plus 5, and that's going to give me an x plus negative 2 or x minus 2. I just want them to look the same, because in these tricky trinomials what I will then do is write down the parentheses that match once, so x plus negative 2, and what was left out alone, I'll write that down once, 2x plus 5, and that gives me my factored form. I can FOIL this and show you it gets back up to this form, but really there's going to be other videos available on my website here, or actually on my YouTube channel, that you can see these tricky trinomials factored out in completion. So what I'm going to do here is I'm going to do some solving for x. I'm going to set x plus negative 2 equal to 0. The x minus 2 is the same thing. If I add 2 to both sides, my answer is x equals 2, so that's one of its locations. This other one is 2x plus 5 equals 0. Subtract 5 from both sides. 2x is equal to negative 5. Divide by 2. X is equal to negative 2.5, or 2.5. So this equation hits the ground at these two spots along the x-axis, has a y-intercept of negative 10, which is kind of good to know kind of what we're actually doing here. We're actually solving the two spots where the x would hit the x-axis, or the line would hit the x-axis. Okay, so for this problem here, I could do the tricky trinomial thing, but what this does, this fits a pattern. The pattern is that if you have the square root of a and you have the square root of c, so like if you take the square roots of both of those, right, that would be a 5 and a 1. If you multiply these together to a c, so if you multiply the 5 and the 1 together and double it, and you get the middle number, then you can use this kind of cool pattern, which is the square root of 25x squared, the square root of 1, and that becomes the numbers in your factoring. Now this is a pattern that doesn't work all the time. You can see that it wouldn't work up here because the square root of 2 is an irrational number. The square root of 10 is irrational, or negative 10 is an irrational number and also an imaginary number. So this works in cases where the first number and the last number in a trinomial are perfectly rootable. Also, the middle number would have to be double these two numbers, because what you're either going to do is double subtract or double add. And again, if this didn't work out for you, we can always go down the path on the right side of this line to show you how you could do this using the tricky trinomial pattern. But this does give you an answer of positive 1/5. But I will now kind of, in case you didn't know that pattern here, I will go through the problem showing you how you would do this the tricky trinomial way. 25 times 1 is 25, and now I need two numbers to multiply to make negative 25, or positive 25, and add to make negative 10. That'd be negative 5 and negative 5. So I'm going to rewrite this trinomial as x squared minus 5x plus 1. Now what I can do is group the first two, so that's going to be 5x removed, so it becomes 5x minus 1. And out of this two terms here, I'm going to remove a negative 1. That's going to make that 5x minus 1. I'm going to write the outside once and the parenthesis once. So now I have my factored problem, and if I wanted to solve for x, I would have 5x minus 1 equals 0. Move the 1, divide by 5, x is equal to 1/5. So I've shown you two different ways you can do the problem. It doesn't matter which one you do. Tricky trinomial, this kind of factoring that I did here and here, will always work as long as the problem is factorable. So for our final two problems here, we're going to have to do a little bit of distribution before we get the problem started. Once we do the distribution, we're also going to move stuff over to one side of the problem. So if I do my distribution here, this gives me x squared minus 3x. Now you'll note I got the x plus 12 over here. I'm going to move that to the right, and the reason why I'm doing that is because I want to have my x squared positive, because that's going to make my factoring a lot easier. Since I now have 0 is equal to x squared minus 4x minus 12, I just have to think of two numbers that multiply to make 12 and add to make negative 4. That would be negative 6 and positive 2. That gives me a negative 12 and a positive 4. So now I'm going to have my x is equal to 6 and my x is equal to negative 2 if I solved these for x. By putting them equal to 0, I think some of you are even figuring out a pattern because it happens to be the opposite of these numbers, which is true. If you're going to move them over to the other side, it just changes them from a positive to a negative. For this problem, I have to do a FOIL. I have to FOIL, which is double distribution of first, outside, inside, last, which would give me 2x squared plus 4x plus 1x plus 2. I would never leave 1x in my final answer, but I find it somewhat useful when I'm actually doing a lot of work over here to try to solve x's and combine x's, that I write it out. Now you'll note that I've got 3 terms over here on the left-hand side of this equal sign, and I should move them over to the right because that will give me a positive x squared if I do so. So I'm going to subtract the x squared, and I'll stack this vertically under the other problem. I'm going to subtract the x, and I'm going to kind of create this little column here where I'm subtracting the 1x from the 4x and the 1x, and then I'm going to, or the 4x, the negative 1x from these two. And then I'm going to add 1 to both sides, and that'll give me my 1 here. So my new trinomial, which is set equal to 0, is going to be x squared, because 2 minus 1 is 1x squared. Again, here's me not writing it. And then these get simplified, so this is plus 4x plus 2 plus 1, which is 3. X squared plus 4x plus 3. So now I'm going to write my 3 as, I think of 2 numbers to multiply to make my 3 to add to make my 4. Here's my x plus 3x plus 1. That's equal to 0. So what that means is my 2 places where it hits the ground at -3, and it hits the ground at -1, using my little shortcut from up ahead. Because that way, if I set them equal to 0, they're just opposite of what they used to be.